Hey geometry peeps, it's time for chapter 6 test review, the last chapter this semester. Can you believe that this semester is almost over? I know you guys will do great, so let's get to reviewing. Number 1, you're talking about the external angles, so remember that means outside. The sum of all of your angles, no matter how many sides, is always the same answer. It's 360. So we really don't care that it's an octagon shape or a star shape or whatever shape it is. It's always going to be 360. Number 2, we know that we have an octagon which has how many sides? 8. And we know that we want to find x. So first of all, we're talking about inside. So we need to know how many degrees are inside. So that's our formula. N minus 2 times 180. Or in this case, 6 times 180. Which gives us 1080 degrees. That's how much all of these angles add up to be. So let's make an equation by adding them all up. We've got x plus 55, 3x plus 20, 4x minus 10, 6x minus 55, 3x plus 52, 3x, and 2x plus 30. All of these angles add up to equal 1080 degrees. So let's combine the left side, all of these x's. If you add them all together, we should have 26x. Add all of your constants, all your numbers together, you should get positive 92. Solve for x. Divide by 26. You should get x equals 38. Now, if you had to find each angle, which some of you are not reading that on your homework and quizzes, you would need to then plug it in. But right now, all we need to know is what x is. Number 3. If the measure of each interior angle is 176, find the number of sides. So here's our formula. N minus 2 times 180. That gives us the sum of interior angles. Divided by the number of sides gives us 176. Let's solve for n. Multiply by n. And then let's distribute 180. Okay, let's bring the 180 to the other side. So now we have negative 360 equals negative 4n. Which is okay, it's negative because we're going to divide by a negative. $90 equals n. That's the number of sides that we have. Number 4, we have a parallelogram. That's important because there's certain conditions a parallelogram has. Remember, I told you in class, if I were you, on my note card for the test, I would write down all those conditions for a parallelogram, rhombus, rectangle, square, kite, and trapezoid, because you need to know those. Well, since this is a parallelogram, you know that the sides are parallel, which means AC is kind of like a transversal. So angle 1 and angle 2 are opposite interior angles, which means they are congruent. So first we need to find x, then we can find the measure of angle 2. Let's set these equations equal to each other. And then let's solve for x. Okay, x equals 25. Now that's great, but that's not what I wanted to know. I want to know what is the measure of angle 2. Angle 2 is 2 times x. Since x is 25, angle 2 is twice that, which is 50 degrees. Okay, number 5. Find the measure of each exterior angle. This is important. Exterior means 360. We have 100 sides, so we're going to divide by 100 to figure out how big each angle is. Each little bitty angle is only 3.6 degrees. Very itty bitty. Turn the page. Okay, number 6. Parallelogram again. So if you picture this, since there is no picture, A, B, C, D. A is 63 degrees. We want to find angle B. Well, a condition for our parallelogram says that these two angles are supplementary. That means they add up to 180. So to find B, why don't we subtract 63 from 180? And we get 117 degrees. Now number 7, you could go ahead and graph it if you wanted to, but knowing those conditions of parallelograms, we don't necessarily have to graph it. We know that if I sketch this out, we have x, y, z, w. In order for a parallelogram to be a parallelogram, its diagonals have to be bisected. In other words, this point in the middle is a midpoint. It's the midpoint of xz, and it's the midpoint of wy. So you could graph it if you wanted to, or you could just find the midpoint of x, z, and wy. So that's what I'm going to do. I'm going to use midpoint formula. Midpoint of xz, we will get 3 minus 2 over 2 for our x, and 0 plus 6 over 2. If we simplify that, that's the point 1/2, 3. We would hope that the midpoint of wy is also that, but we need to prove it. So let's do the midpoint of wy, just to make sure. That midpoint is -2 plus 3 over 2, and 8 minus 2 over 2. Hey, it's the same point, which is what we wanted. So that is the intersection of our diagonals. And hopefully if you graphed it, you would get the same point. You would go 1/2 over on the x-axis, up 3 on the y. Okay, number 8. Here's where those conditions also come in handy. We need to know if this is a parallelogram. One of our theorems and conditions talks about opposite sides, and it says that both pairs have to be congruent. If I only had marks on one pair, that wouldn't make it a parallelogram. You cannot assume that the other set is congruent. But this, I have one pair congruent, and I have another pair that is congruent. So this is a parallelogram. And it says to justify. So my justification is that both pairs of opposite sides are congruent. That is a theorem or a condition, but I am not sure what number it is. So if you have the number, you can also write that on there, but this is what I'm looking for. The explanation. Number 9. This is another one you could graph and then use slope formula from your graph, or you could just do the slope formula in the space provided. It's up to you. If I think about that this is a quadrilateral, so 4 sides, one of the things or conditions that has to be met for a quadrilateral to be a parallelogram, if I'm using slope, is that I want to prove AB is parallel to DC, and I also want to prove AD is parallel to BC. So I could use my slope formula. Let's find the slope of AB, which remember is rise over run. So we will get 7 plus 1 for our change in y, 5 minus 1 in our change in x. That's 8 over 4, which reduces to just 2. Now let's see, remember, here's AB. Let's see if DC is also 2. That's negative 3 minus 5 over negative 6 plus 2. That simplifies to negative 8 over negative 4, which is also 2. So AB is parallel to CD. Now, you might want to stop there because one pair of sides is parallel, but that does not make it a parallelogram. Both sets have to be parallel. So now we need to prove AD and BC are parallel. So we're going to do the same formula, but for BC and AD. The slope of BC is negative 1 plus 3 over 1 plus 6, which is 2/7. And the slope of AD is 7 minus 5 over 5 plus 2, which is also 2/7. So BC is parallel to AD. We have both sets of lines that we just proved are parallel. So is this a parallelogram? Yes. And here's my justification or my reasoning right there. You have to have proof. You cannot just say yes or no. Alright, number 10. If the slope of AB is 1/2, the slope of BC is negative 4, the slope of CD is 1/2, we want to find the slope of DA. So if you think about our little picture we drew up here, remember 2 slopes are the same and 2 slopes are the same. We have 2 slopes already that are 1/2, but we only have one that is negative 4. So in order for this to be a parallelogram, DA also has to be negative 4 for it to be met. Number 11. We have a key word here, and that is rectangle. That means all of these angles are 90 degrees. I want to find the value of x. So my equation is to add both of those angle measures and set it equal to 90. 6x plus 20 plus 3x minus 2 equals 90. Let's clean up the left side. Okay, let's go ahead and solve for x. Nine x equals 72. So x equals 8. Okay, number 12. We know that ABCD is a parallelogram. Angle A is 90. We want to know whether ABCD is a rectangle. So think about this. I sketch it out. If one angle is 90, all the other angles have to be 90. So if all four angles are 90, it's a rectangle. So let's state that. Yes. Here's why. One right angle means the others will also be right angles. If all the others, that means we have four. Four right angles means the quad is a rectangle. You do not have to have that exact definition, but as long as it's close, it will work. Okay, 13. ABCD is a rhombus. So let's sketch this out. Diagonals intersecting at E. Remember, all of our sides are equal, and remember our diagonals mean that they bisect the angles. So if ABC is 4 times BAD, so let's say BAD is X. ABC is 4 times that. We want to find EBC. Well, EBC is this angle here. It's half of ABC. So if ABC is 4x, EBC is 2x. Okay? Well, that's great, but we want to know actually how many degrees. So we need to look at ABC, 4x, and BAD. So I have this angle and this angle. They are supplementary. So x plus 4x equals 180. Let's solve for x. Okay. X equals 32, but that's not what I want to know. I want to know the measure of EBC. So let's substitute 36 in place of x. EBC is 72 degrees. Excellent. Okay, number 14. You know that it is a square. So let's graph those points. I'm going to move my graph paper over here so you can see it. And we've got Q at -2, 8. We've got R at 5, 7. S is at 4, 0. We want to find the coordinates of P. So remember, a square means that all my sides are equal, but they also right angles. So my slope, QR, has to be the same. What's my slope for QR? Well, QR's slope is rise up 1 over run negative 1, 2, 3, 4, 5, 6, 7. Okay, so if I use that, I should be able to find point P from S. 1, 2, 3, 4, 5, 6, 7. Point P. What is the coordinate of point P? Yep, negative 3, 1. So let's go ahead and write that down. Awesome. Make sure you also know the conditions for a square in that it has to be a rhombus and a rectangle, because sometimes you may not be able to just use the slope. You may have to do what we did in class yesterday, which was use the diagonals. So make sure you know those conditions also. Number 15, this is isosceles, so that means MN is the same length as OP. And it also means that our base angles are the same. So that means that angle M is also 74 degrees. Being an isosceles trapezoid, it means that these angles up top, M and O and PON, are supplementary. So angle MNO is supplementary. That means 180 minus 74, which is 106. Now the reason why we found this angle, this whole thing, is because we want just this little piece right here. And since this is 90, that means this angle right here is also 90. So angle QNO is also 90. So if the whole thing is 106, this piece is 90, we can find that little teeny tiny angle, angle M and Q, by taking 106 and subtracting 90. We get 16 degrees. Okay, number 16. Again, you can graph this. It's got really big numbers, so I am not going to graph it. But I am going to use the conditions for a trapezoid to show you how you can prove it without graphing it. In order for something to be a trapezoid, it has to have one pair of parallel lines. So if I sketch this out like this, and I want to prove that AB and DC are parallel, okay? So let's find the slope of AB. So remember, that's change in Y, change in X. Okay, so there's that one. We want to see if CD is also 3. So let's do that one. okay, those are parallel, which is what we want. We want AB to be parallel to CD, but we also want to prove that AD and BC are not parallel. Their slopes need to be different. Okay, so over here I'm going to talk about AD. AD is -19/-10, and then we want to compare BC. It could be anything other than 19/-10. So BC, we've got -1/-16. Hey, those are different. That means this is a trapezoid because AB is parallel to CD. Oops. AD is not parallel to BC. Okay, try to set up number 17. I'm going to give you a second. I've got to go grab my power cord because my laptop is going to die. So don't go anywhere. Okay, sorry. I thought maybe my laptop would make it and it didn't. Alright, so we've got the length of the median. So let's sketch out our trapezoid. And remember, a median, middle, or mid segment is right here. We know that this is 17. We know that one base is 2x plus 4. Doesn't really matter which one you labeled it. And we know the other base is 8x minus 50. So our mid-segment formula says that this, the 17, equals 1/2 your two bases added together. We need to find the value of x. So first, before you distribute this, I would just multiply it by 2. Get rid of it. So we have 34 equals, let's combine our x's, 10x minus 46. Let's solve for x. Add 46, and we get 80 equals 10x. Okay, solve for x. You should get x equals 8. Excellent. 18. We know that it's a kite, so that means our diagonals are perpendicular. And since RA is 15, BD is 16. Now, because this is BD, we know that BR and RD are the same. So that makes RD 8. That's important because we want to know how long AD is. If I pull this out to show you the triangle, you should see, and remember Pythagorean theorem. That's what you need to do to find x. 15 squared plus 8 squared equals x squared. Okay, let's combine those. To solve for x, we need to take the square root. Not divide by 2, but what times itself. 17 is x. So the length of AD is 17. Okay, 19 through 25. These all have to do with those conditions I was telling you about, and I'm reminding you to put on your note cards. 19, a parallelogram always has 4 right angles. Keyword always. It may sometimes, but not always, so this is false. 20, the diagonals of a rhombus always bisect the angles. That's true. There is a theorem about that. 21, a rhombus is always a square. Again, keyword always. Sometimes yes, sometimes no, so this is false. A rectangle is always a square. Again, there's that sneaky word always. It's not always. Sometimes it is and sometimes it is not. 23. The diagonals of an isosceles trapezoid are always congruent. That is true. There is a theorem about that in chapter 6, lesson 6. 24. The median of a trapezoid always bisects the angles. Think about what a median is. A median does not bisect angles. It bisects sides. So this is false. And number 25. The diagonals of a kite are always perpendicular. That is true. We used that in number 18, and it is also a theorem. 26, I'm going to let you do on your own. If you figure it out, I will give you a small but fabulous prize on Wednesday.